Okay, coming to the next topic, ionic polarization. In our previous class, we have completed about electronic polarization and expression for electronic polarizability. So alpha is equal to 4 pi epsilon r cube. This is the expression for electronic polarizability. Yeah, next coming to ionic polarization. So this is here consider a molecule HCl which consisting of H plus and Cl minus ions. So the ionic polarization occurs when atoms form molecules, and it is mainly due to a relative displacement of the atomic components of the molecule in the presence of an electric field. So when electric field is applied to molecule, just like a HCl atom, a HCl molecule, so the positive ions displaced by distance x1 to the negative side of electric field, and negative ions displaced by the distance x2 to the positive side of the field. That means the HCl molecule, whenever it is placed in the external electric field, so it becomes dipole. H plus and Cl minus are separated by some distance. Yeah, coming to this one. So this is the electric field which is produced with the help of this capacitor. So in this electric field, consider one molecule, HCl molecule, say which becomes a dipole here, H plus and Cl minus, that is cation and anions which are separated at distance x1 and x2. So the resultant dipole moment mu is equal to q into x1 plus x2, that is charge into the distance between the two charges, the product of the charge and the distance between the two charges. So that is given by dipole moment of the given dipole. So on this molecule or on this dipole, that is in the presence of electric field, so the force acting on this dipole is given by F is equal to QE. So again, on this dipole, so a restoring force is acting. The restoring force acting on this dipole is given by m omega naught square x, because here the restoring force constant depend upon the mass of the ion. So, and the natural frequency omega naught, and is given by here m omega naught square x, where x is the distance between these two ions, x1 plus x2. Here consider x1 and x2 are the displacement of positive and negative ions, where m is the reduced mass of this dipole. So here capital M is the mass of the negative ion, small m is the mass of the positive ion, omega naught is the angular frequency of the respective ions. Now because of here because of these two forces, and these two forces are equal. So the force due to electric field F is equal to QA, and a restoring force acting on it both are equal. So by equating these two, X is equal to small e into E bar divided by M into omega naught square. So that is equal to small into E bar by omega naught square into 1 by small m plus 1 by capital M. Say this is known as here the reduced mass of the given dipole. Now the induced dipole moment is given by mu I is equal to E into x1 plus x2. But we know that the value of x1 plus x2 is equal to E into E bar divided by omega naught square into 1 by small m plus 1 by capital M. By substituting the value of x1 plus x2 in this equation, so mu I is equal to small e square into capital E divided by omega naught square into 1 by small m plus 1 by capital M. Say here from this equation we can write so ionic polarizability alpha I is equal to pi by E bar, but pi is nothing but mu I per unit volume. So mu I by E bar, which is equal to small e square by omega naught square into 1 by small m plus 1 by capital M. Say this is the expression for ionic polarizability. Say this ionic polarization occurs up to the frequency range 10 power 13 hertz, that is up to IR frequency range. We have to observe this ionic polarization. It is a slower process compared to electronic polarization, and it is independent of temperature. So, and coming to the next one, orientational polarization. So it is also called dipolar or molecular polarization. So the molecules such as here H2, N2O to Cl2, CH4, CCl4, they does not carry any dipole because center of positive charge and center of gravity of negative charge, they coincides. Okay. On the other hand, just like here, consider other molecules here, HCl, H2O, CH3Cl, and ethyl acetate, etc. These are polar molecules. They carry the dipoles even in the absence of electric field because these are polar molecules. However, the net dipole moment is negligibly small since all the molecular dipoles are oriented randomly when there is no electric field. In the absence of electric field, so all the dipoles which are arranged in a random direction, so the net dipole moment becomes zero. But in the presence of an electric field, all these dipoles orient themselves in a particular direction of the field. As a result, the net dipole moment becomes enormous. So this orientation polarization occurs up to frequency 10 power 10, from 10 power 6 to 10 power 10 hertz. It is a slow process compared to ionic polarization. It greatly depends on temperature. It is a temperature dependent. Yeah, coming to orientational polarization, N is PO is equal to N into mu bar, where this is equal to N into alpha naught into alpha Y into E bar, where alpha Y is equal to mu square by 3 kT. Where alpha Y is equal to, so alpha naught is equal to mu square by 3 kT. So this is expression for orientational polarizability alpha O. So mu square by 3 kT, which depends on temperature, absolute temperature. Yeah. Coming to the last one. So the total polarizability of a given electric material is equal to the sum of the electronic polarizability, ionic polarizability, and orientational polarizability, and their expressions also substituting in this one. So expression for electronic polarizability is nothing but 4 pi epsilon naught r cube. For ionic polarizability, E square by omega naught square into 1 by capital M plus 1 by small m, and for orientation polarizability, E square by 3 kT. So this equation here, this equation is called Langevin-Debye equation for total polarizability in dielectrics. Now coming to the graph here. So the frequency values are taken along x-axis, and the total polarizability real part values are taken along y-axis. Now here, the electronic polarization in the electric materials generally observed up to UV frequency range, that is around 10 power 15 to 10 power 16 hertz frequency. So, and ionic polarization contributes up to frequency IR here, that is 10 power 13. So IR frequency. And coming to dipolar polarization or orientation polarization will be observed up to microwave frequency. Yeah. Coming to internal fields or local field. So generally, in the given dielectric material, so the dipoles or induced dipoles are existing because it is placed under application of electric field. Now this is a capacitor. Between the plates of the capacitor, just you have to apply an electric field. So within this electric field, you have to place a dielectric material. So this dielectric material gets polarized because of this applied electric field. That means the induced dipoles are existing within this dielectric material. The number of induced dipoles are existing per unit volume is nothing but polarization vector. Now, in this dielectric material, consider a point A at which you have to consider one atomic dipole. Yeah, coming to this one. Consider a dielectric be placed between the plates of a parallel plate capacitor, and let there be an imaginary spherical cavity around atom A instead of the dielectric material. Consider atom A. Around this atom, just you have to consider spherical cavity. So on this atom A, how many number of fields are acting? So that is here, that concept here, it is called internal field or local field, which is defined as the field acting at the location of an atom, okay, within the electric material, is known as local or internal field E bar or EI. So the internal field or local field must be equal to the sum of applied field, external applied field E bar plus the field produced at the location of the atom by the dipoles of all other atoms. That means at a point A, that is here around the point A, around the point atom A, say here consider a spherical cavity. So on this atom A, how many number of fields are acting? So the electric field acting on this atom because of the capacitor, because of this electric material, because of the neighboring dipoles that is inside the spherical cavity on the charges on the spherical cavity. So that is here. The internal field at the atomic site A within the electric material can be made up of 4 components: E1 bar, E2 bar, E3 bar, and E4 bar. So E1 bar is intensity of electric field due to capacitor plates. E2 bar is the intensity of electric field due to okay, dielectric material, because on this dielectric material electric field is also generated, okay, which is opposite in direction to the applied electric field because of this capacitor. So that is E2 contribution. And E3 is the intensity of electric field, okay, due to atoms contained in the cavity. Okay, we are assuming a cubic structure, so E3 is equal to 0 inside the spherical cavity. Okay, E3 is nothing but electric field intensity due to okay, atomic dipoles inside the spherical cavity, and E4 is here due to polarized charges on the surface of the spherical cavity. So on this spherical cavity also there are charges here. So because of these charges on the spherical cavity, so the field due to charges on the spherical cavity is nothing but E4. So because of all these 4 contributions, so you have to calculate the local field. EI is equal to, yeah, EI is equal to E1 bar plus E2 bar plus E3 bar plus E4 bar. So totally you will get the expression for local field. EI is equal to E bar plus P by 3 epsilon naught. And then after you are going to okay, learn about Clausius-Mosset relation, because the local field expression for local field and Clausius-Mosset equation both are very important questions. So up to here, just we have to complete different types of polarization, that is electronic polarization and ionic polarization and orientation polarization. So the values of electronic polarizability, ionic polarizability, and orientation polarizability, and okay, the frequency versus polarization, total polarizability graph here. Okay, so up to this one it is enough because we have no time. In our next class we will start the remaining. Okay.